Welcome to Zaption Tour 7.1, 0 and negative exponents. We're going to dive right into this. Box number 1, I'm trying to figure out what 2 to the 0 and 2 to the negative 1 exponent must be. Now we've already dealt with exponents before in algebra, so I want to try and see if we can get a pattern here. So 2 to the 0, this is a big question for us, and 2 to the negative 1. What are these values? What must they be? Okay, let's get into this. 2 to the third means 2 times 2 times 2. Well, that's just a value of 8. That one should be no surprise to anybody in the room. 2 squared means 2 times 2, and that gives us a value of 4. Okay? 2 to the first is just the value of 2. So right now, do we see a pattern? How do I go from the number 8 to the number 4? How do I go from the number 4 to the number 2? Well, to get from 8 to 4, hopefully you see that we just divide by the number 2. To get from 4 to 2, again, we divide by the number 2. So assuming that this pattern continues, if I take the number 2 here and I divide it by 2, what number would I get to go right here to figure out the question, what must 2 to the 0 be? Well, 2 divided by 2 gives me a value of 1. Okay, then again, if I take the number 1 and I again divide it by 2, what must be true for 2 to the negative 1? Well, 1 divided by 2 is just 1/2. So notice that as my exponents are decreasing by whole integer values, the pattern continues. I'm just dividing out my base on the left-hand side, or on the right-hand side, excuse me. So it must be true that 2 to the 0 must be a value of 1, and 2 to the negative 1 must be a value of 1/2. And this is something we formalized in box number 2. So here is the formalization of the pattern that we just saw in the first box. It says 0 and negative exponents. For every non-zero number, a, if I take a and raise it to the power of 0, I get the number 1 back. So as an example, for us to quickly realize, if I take the number 3 and I raise it to the power of 0, it's the number 1. If I take the number 5 and I raise it to the power of 0, it's also the number 1. If I take the number negative 3 and I raise it to the power of 0, I get 1. If I take the number negative 9 and I raise it to the power of 0, I get 1. Any non-zero number raised to the power of 0 is going to give me 1. Okay, what about negatives then? Number 2, every non-zero number, a, and every integer, n, a to the negative n is going to be worth 1 over a to the positive n. Very, very big idea here. So let me give you some examples of this one. Okay? So if I have 3 to the negative 2, it's the same thing as 1 over 3 to the positive 2, which you could continue on and say that would be 1/9. If I take 5 to the negative 1, it is the same thing as 1 over 5 to the positive 1, which is just 1/5. So these are two very, very important concepts for us. A to the 0, as long as a is a non-zero number, will always be 1, and a to the negative n, as long as a is non-zero and n is an integer, will be 1 over a to the n. Box number 3 is some examples of simplifying powers. So here we go. If I take 9 to the negative 2, it is 1 over 9 squared, according to my negative exponent rule, which gives me 1 over 81, and that is how I would simplify. Number 2 says 1 over 3 to the negative 2. Well, since I have a fraction already and my negative exponent is on the bottom, it basically just gets moved to the top. So this is going to be 3 to the power of 2, which gives me a value of 9. Now a lot of students don't see that right away, so let me give you an alternate method. I could write this as 1 divided by the fraction of 1 over 3 squared. Notice that I'm still applying the same rule in the denominator, and I'm getting, for a value, if I get 1 over 1/9, which of course I'm dividing a fraction by a fraction would still give me 9. So either way, however you see it, you still get the right answer of 9. Okay. Negative 5 to the negative 2 is 1 over negative 5 to the power of positive 2. Notice that my negative stayed with my negative 5 because it was a parentheses there. Okay? That would give me 1 over negative 5 squared is a value of 25, so I'd get an answer of 1/25. Negative 6 to the 0, as long as it's a non-zero number raised to a power of 0, will always give me a value of 1. 4 to the negative 3 is 1 over 4 to the positive third, which is 1 over 64. 4 times 4 is 16. 16 times 4 is 64. And finally, 8 to the negative 1 is the same thing as 1 over 8 to the positive 1, or just 1/8. So there are 6 examples of simplifying powers. Box number 4 is an example of simplifying some exponential expressions. So these are expressions that have exponents, and we want to simplify them. Here's number 1. So I have 5a cubed b to the negative 2. Well, notice that the only variable that has a negative exponent is the b. So that's the only one in which I need to apply the rule of negative exponents. So this is going to give me 5a to the third multiplied by, this is going to be 1 over b to the negative 2. Or, sorry, excuse me, 1 over b to the positive 2. Which simplifies down to 5a cubed divided by b squared. Some students like the idea that if my exponent with my negative is on the top, it just gets moved to the bottom of the denominator and it becomes positive like it did here. And others like to actually just show the work just like I did here. However you see it is fine with me. Okay? So let's take a look at this one, number 2. Notice that the only one that has a negative exponent is in the bottom of my fraction, right? This is the only variable that has the negative exponent, so therefore it's going to be moved to the top. So when we simplify this down, we get just a regular old x to the 5th for the answer. Let's do another one that has a combination here really quickly here. I'll make this up for you, number 3. Let's say I want this. Let's say I want 5x to the negative 2, b to the third, all divided by a squared y to the negative 1. Here's how I would like to teach this. So notice that the x is the only one that has a negative exponent, and the y is the only variable that has a negative exponent in the denominator. So x has a negative exponent in the numerator, y has the negative exponent in the denominator. So these are the only two that are going to be trading places with each other. So x squared is going to come down, y to the first is going to come up. So when we simplify this, we would get this. 5 b to the third, y to the positive first, over a squared x squared. So notice, right, that the x squared now is on the bottom with a positive exponent, and the y to the first is on the top of the fraction with a positive exponent. Some students really like that method. Box number 5 is an example of evaluating an exponential expression. So we have 3x to the third, y to the negative 2. What does that expression become when x is worth negative 2 and y is worth negative 3? So some people like to plug in the values first, and others like to simplify it first. It doesn't matter. I'm going to go ahead and simplify this first. So I'm noticing that the y is the only exponent that has a negative attached to it, or the only variable that has a negative exponent. So it's going to move to the bottom of the denominator. So this is going to be 3x to the third divided by y squared. Now, once I've simplified my expression, I'm going to plug in my values. So this is going to be 3 times 2 to the third, all divided by negative 3 quantity squared. I just substituted in the x and the y. So this gives me 3 times 2 squared is 8. And this gives me negative 3 squared is the number 9. 3 times 8 is 24 over 9, and that would be my answer.